Welcome, this is lesson 1 of algebraic modeling and unit analysis. Now when we think of models, sometimes we don't always think of algebra, but I wanted to explain that algebra's been around a long time. In fact, way back about, I wasn't alive, 4,000, 5,000 years ago, there was one day that it's told that a man built a boat. That was huge, but the instructions for that boat weren't in feet and inches. It was in a cubit. And I don't know if they used handspans, I don't believe so, in that measurement, but he was told how to build the boat by cubits and handspans. So I just want to explain that he was told 300 cubits. And he was supposed to make it, that was the length. The width was 50 cubits wide. And the height was to be 30. And I can see right now, see, I'm already running out of space. And this poor guy, he didn't even have a tablet to work on. So I would guess that even back then, when he told his sons what he was doing, he used algebra and said it's 300 cubits plus 50 cubits plus 30 cubits high. And see, he used that variable, c equals cubits. Now in reality, I wasn't there for that, but I want you to know that algebra today is just as important. Let's say that you just moved into your house and you're sitting there trying to figure this out. Your mom went to the store and she forgot to get the measurements for the window that she's getting screened for. Or let's say she's getting trim to go around it. And you look around your house. You guys haven't unpacked any of your measuring tools or anything, but she calls you up and says, oh my gosh, I need to know the size of that window. You say, Mom, I'm figuring as fast as I can. And you find a stick and you find a pebble. And you take that stick and you measure across here and you find that the length of that window is 2 sticks plus 3 pebbles. Well, then it comes in really handy. Now you have a sense of the size or the length of that window, and you can abbreviate this so that we don't have to keep writing it time and time again and just say, well, it's 2, let's go with T for stick plus 3P for pebble. Okay? Now, you've just used algebra and you've just explained what your variables mean. That's why we have all these x's and y's as we're representing something. Could the size of this stick change? Yeah, but you know that it was 2 of those sticks. So what you immediately do is, using your skills from science class or even my class, you build your little trebuchet or your catapult, and you catapult this stick and this stone across the neighborhoods over to the hardware store where your mom's standing trying to get trim to go around that. And now at the hardware store, she has the stick and the pebble. And she says to the man, I know that the window is 2 sticks plus 3 pebbles. And I'll just put a P above that and a T above the stick. Okay? And so the man says, well, I've got a measuring device here. I can measure how long your stick is, and I find that it's 18 inches. And I see that your pebble is 2.5 inches. That's a big pebble. That's more like a rock, but it did well in your little slingshot device. So, now you have to figure out, okay, how many inches do I need? Well, in this case, you'll have to plug in 18 inches for your stick and 2.5 inches for your pebble. Evaluating that, you need 36 inches plus 2 times, well, I'd go 3 times 2 is, 3 times 2 is 6, and then 3 times a half would be 1.5, so 7.5 inches, okay? Now we find that we need 43.5 inches of the trim to go along the bottom of that window. We have used so much algebra. Now I need to go back through and explain what some of these things are, because you'll be using them in class tomorrow. First off, what he came up with way back 4,000, 5,000 years ago, this is called an algebraic expression. It is an algebraic expression because it has the letters in there to represent cubits. If it only had numbers, it would be a numerical expression. Please pause the video and write these down. So this is algebraic. If it had only numbers, it would be numerical. Now, within that expression, let me just give you another example of one. Whoops, I don't need to be moving that around. Another example of an expression, 2x squared minus 16x plus 32. Now realize that x, we don't know what it stands for. They may come in and tell us later, or they may just want to leave us in the dark on that. But here are some important parts of expressions that you need to know, because I'll be talking about them. This entire thing is called a term. Terms are easily seen when we put a plus between everything. Now this one already has a plus, but on this one it was important to slip the plus in front of the minus because that minus is attached to the 16. There's another term, and there's the final term. So terms are separated by addition signs. Okay, this is 3 terms. We call that, I'll just give you a heads up for later on, it's a trinomial. It is a trinomial because it has 3 terms in it. Now, next thing is these terms have some parts within them. This numerical part, negative 16 and 2, they happen to be next to the letters. That separates them from this number here. This number can't possibly change its value. These will change the value of the term when we plug a number in, such as your 18 inches for your stick. It changed the value of this term to be 36. Since this one will never change its value, it's called a constant. It is still a term of the expression, but it is a constant term. Now these, because they have that letter that can be replaced by anything, it's called a variable because it can vary. Now the number in front of the variable that's attached directly to it, that's called a coefficient. Okay, so those are just parts and things that you need to know vocabulary-wise coming into class. So the first thing that you're asked to do tomorrow in class will probably be to write this expression as a sum. And what I'm meaning for you to do is slip a plus right in between your terms there. Now that they're separated with the plus, I will have you identify all the parts. I also kind of want to know, hey, why is it easier to have the plus in there in order to see that that's a negative 4? What mistake could be made if you didn't put the plus in there? So think that through. Go ahead and write it down right now while you're thinking about it if you want to. Okay, so now I want to explain factors. A word that you should be familiar with are parts of a product. In other words, they are multiplication. So when I show you this next expression, these are expressions unless I put an equal sign in there, then they become equations. So this is an expression. How many factors are there in this equation? Or in this expression, I'm sorry. And why would 4x minus 10 be considered a factor? Let's talk about that when you come into class. I'm not going to tell you. I want you to think these things through before you come to class. Leave some space in your notes. Okay? So, why are there two factors? Next thing in this is we want to come back to something that Joe's mom did. I don't remember what I named him, but we'll call him Joe now. When Joe's mom went to the hardware store and she had that man measure these, that was called evaluating. Ooh, I want to switch colors so that you can see it easily. That's called evaluating in algebra. That means that you're plugging in a given value for your variable, okay? And anytime you measure in variables, I will have you guys measure in the room and different things with odd things, spaghetti, all different things. I want you to make sure and define for me, just like I did here, what each one is equal to. Okay, that's called defining your variable. We need to know. So now sometimes we can even use this, for example, in situations where you might want to, know the speed of something. I just shift gears a little bit here. Let's say that Juan is out throwing the baseball. Ooh, he's got quite a pitch there. And he threw this baseball through the air. And he wants to know, hey man, am I getting as fast as some of these pro baseball players? In which case, well, you need to figure out, well, how do we convert to miles per hour? We know that he threw 44 feet in a half a second. We measured that out. So this is when it can get kind of fun using the different units where we can convert. This is called unit analysis, and we'll play with it more in class, but it's really handy as you're measuring things. Feet per second doesn't really mean a lot, although we could switch that to being 88 feet in 1 second. So for sake of the fraction there, let's go ahead and switch this over. 88 feet in 1 second. And now I say, well, I want to know how many miles per hour. Because the pros throw, what, 90, 120 miles an hour? I don't know. But I know that it's pretty fast. It's faster than my car goes. So now we want to get this to miles per hour. In doing unit analysis, we want to get rid of the feet and get it to be miles. So I say put it crisscross so that it can cancel as you're multiplying. Put your feet down here and put your miles up here. Now you need to find out how many feet are equal to a mile. 5,280, because I have that one memorized, I use it so much, is 1 mile. And now how many seconds in an hour? Well, we know that there's 60, let me think, we want seconds. Well, let's go with minutes first. So if we want seconds up here, seconds per minute, and minutes per hour, then we go 60 seconds in 1 minute, and 60 minutes in 1 hour, So our units line up, feet, cancel. Our second cancels with that second. Our minutes cancel with that minute. And we end up with hours on the bottom, miles on the top. And now we just grab a calculator, real handy here, and we figure this out. We say 88 times 60 times 60 equals, divided by 5,280 equals, he's throwing that ball at 60 miles an hour. Okay, 60 miles per hour. Now, you might say, well, why did you do all this work if you were going to grab a calculator? The reason I did that, you heard me kind of pause and slow down, was making sure that I was canceling my units correctly. Sometimes that's the only way I know how to set up a problem, is by unit analysis to make sure that I'm getting where I want to go. We will be practicing that in class as well, unit analysis, and that's kind of how I use it really, is checking speed. The other thing that you'll be doing is you will be practicing with our properties. Super important that you know commutative, associative, and distributive property. These are all the properties. Now, I'll be honest, I use these mostly at the front of the room. When we start working on problems, I might say, okay, what's the first step in simplifying this expression? Because that one